Hey, you tens, how's it going? How is everybody this morning? Has everyone had a nice weekend? It's lovely to see everybody. Right. How is everybody? Oh, there you go. Sounds good. I like it. Right, gonna do the reg. Gonna do the register. Have I just seen Amani? I don't know Amani yet. No, Amani. I don't know. Zach, do we have Zach? Is Zach in the house? Zach's not in the house yet. Oh, man. Sophia's here. Tiffany. Tiff. Kayla. Is Kayla here? No Kayla yet. Mel. I think I've seen Mel. Dom's here. And Audra. I haven't seen Audra in a while. I haven't seen Audra in ages. Lara's here. I know that. I've got Atia. Got Caitlin. Good morning. Got Dom. We got Ryan. I think Ryan is second in the house. I like it. Got Lynn. Got Libby. Yes. Helping. Yeah. Whoop, whoop. Only a couple of people missing now. There's Zach. Sup, Zach. Sup, dude. Sup. Oh, I just did that on, oh no. Did that live on YouTube. Has been embarrassing. Oh no. So, brah. I've lost my mind. It's gone. Right. Okay. So Kayla's not here. Amani's not here, and Audra's not here. Haven't seen. I'm gonna mark them as missing, and we will crack on. Krakosia. It's a Krakosian for crack on. Yeah. No Amani. No Kayla. Okay, save. Amazing. All right, guys. Right. There we go. Okay. Pause that. Pause. Okay, I'm just checking. Okay, right. Okay, solubility rules. That's what we're doing today, folks. Whoop, whoop. Yeah. Okay, share screen. And you guys had no homework. Wow, that was good, wasn't it? No homework. Amazing. Right, get rid of my keyboard. Oh, right, okay. Krakosia. Let's crack on. Right. So today's lesson, solubility. Yep, so we're doing solubility rules. Solubility rules. It's a bit like chemistry. Chemistry rules. It's amazing. Love chemistry. Solubility. There we go. Like that. Boom. Okay, you can even put the smiley face into your notes, guys, if you want. I would. Obviously. Right, learning objectives. 3 learning objectives today. Number 1 is I need you to know the solubility rules. Yeah, that's the first thing we need to do. You need to know them. Yeah, solubility rules. Number 2, I need you to understand how solubility rules ties to reactions. Yeah, understand how solubility affects. By the way, don't ask me how I know. I can't explain it to you. How solubility affects reactions. And then I need you to be able to write symbol equations. We know, by the way, that you don't actually need the word symbol here. Don't actually need it. Yeah. Because if someone says write an equation, you assume it's symbol. Yeah. The only time you do word is when they say word, because words are rubbish now. You've left them behind in the dust. Yeah, write symbol equations with state symbols. Stat symbols. Yeah, there you go. There are my learning objectives. I like it. Okay, so no one said anything on the chat yet. Can I say, Dom, I'm a bit disappointed. You know, you always turn up and you're so lovely about my lessons. Yeah. You're always like, chemistry is amazing. It's the best lesson of the day. And you've said nothing, Dom. Like, Dom, I'm a teacher. I need this kind of positive feedback, Dom. I really need it, Dom. I really do. Okay, so Kayla. I'm a bit sleepy today. It's amazing. I love it, Dom. Hi, Kayla. Nice to see you. I've updated the register. It's lovely to see you. Oh, Amani's just rocked up. Ugh. Okay. Only Audra missing now. Update register. Done. Okay. Okay, so 3 learning objectives. I love the fact that we've hit all of them today. Acknowledge, and understand, and an able to. We've got all of them. Yeah, got all the best ones. Okay, so solubility rules. So here's our knowledge. What? Solubility. Solubility rules. Boom. Okay. So there are 3 rules for solubility. And by the way, I'm sorry that you know, some people might not like the way that I do this. I do it slightly differently than other people. But first of all, let's talk about what solubility is. So let's just this is a definition. For solubility. I think that's definitely, we picked up in our very first lesson of acid bases. No, I tell a lie. We were looking at solutions and solubility and solvents and solutes and solutions and saturation and sediment and all that stuff. And this definition is the one that I need to reinforce. This comes up very frequently at GCSE. It's super common. Yeah, so solubility, the mass, keyword, underline it, please. Underline it. The mass of solute that can dissolve in 100 grams of water at 25 degrees Celsius. So it's actually a measure, yeah? And this is an Edexcel speciality, this solubility definition. Yeah, the real one is the mass of solute that can dissolve in a fixed quantity of water at a fixed temperature. Because we realize that the volume of water, if you've got more water, then you can dissolve more solute. Yeah, if you've got it hotter, we reminded ourselves that if you increase temperature, then you increase the solubility of a solid solute. You would decrease the solubility of a gaseous solute. It's cool, isn't it? It's all cool, kind of cool. But that one comes up frequently. So put this one in a bubble. Yeah, this one comes up a lot at GCSE. Yeah, and technically it's from Key Stage 3. Hence why I like to reinforce it, because they ask it. It's kind of rare for them to ask a question from year 7 in a GCSE exam, but that one appears. Okay, so the next thing is we now need to do our rules. Yeah. So rules. So rule number one. I made that too big. It's rubbish. Make that prettier. There we go. Rule number 1. It's still rubbish. I want to make that better. Rule number 1. The funny hashtag? Is that a hashtag? So if they ask you solubility of something but without a temperature, do we assume 25 degrees Celsius? Yes, Libby, that's absolutely right. You assume 100 grams of water and you assume 25 degrees C. Spot on. Absolutely right. You have to. They're saying that the solubility that Edexcel are doing, they're being rather clever. They're saying that they don't have to actually give you a temperature and a volume now, because it's in the definition from Edexcel. It is used in other places as well. I do understand why they're giving a temperature and a volume. I do get that. I'm also going to put a nota bene on here as well. Nota bene, 100 grams of water is equal to 100 centimeters cubed of water. It's kind of cool. I always love that one. Yeah, they equal the same thing. Yeah, it's actually a really lovely thing because the density, this is due to the density of water Yeah, density of water is 1 gram per 1 centimeter cubed. 1 gram per centimeter cubed. And we love the little slash. Yeah, it's nice to have that. Okay, so rule number 1 for solubility, everything is soluble. I love that rule. Everything is soluble. Now, that's hilarious, isn't it? Because it's like this huge rule, and everyone goes, what? You can't give that, you can't state that everything is soluble and then go, well, number 2, except. Yeah, but it's actually quite a useful rule. If it doesn't fit the exception, then it's soluble. That's the way you do this. If you don't like doing that, and so I know that some students don't, you can put almost everything is soluble if you like. I actually, annoyingly, I don't like the word almost. I just like to say everything is soluble. So if somebody randomly throws me a solute, e.g., yeah, if someone randomly throws me a solute, like, oh, sodium chloride, soluble or not soluble, I'm like, everything's soluble. It's probably, excuse me, it's probably going to be soluble. Yeah. It's just a really lovely, I would make an assumption that it's going to be, because there's actually very few exceptions. Yeah. Okay. So now we pick up, and now this is where we need to actually expand on the everything is soluble. And what I now need to talk about here is NAGSAG. Yeah, this is how I teach solubility. Yeah, NAGSAG. And I'm going to change my color there. Yeah, there we go. NAGSAG. And at this point, people go, what's NAGSAG? And I'm like, this is just a way of being able to recognize the soluble ones. And there's a reason for its particular structure. So the first thing to realize is this one. Yeah. So we've got the N stands for nitrates. Yeah. And here's the rule. And this one is true. And this is absolute truth. All nitrates are soluble. Yeah. All nitrates are soluble. Fact. Yeah. I'll put exclamation mark, brackets, fact. Yeah. All nitrates are soluble. Silver nitrate, potassium nitrate, lead nitrate, every nitrate is soluble. Love that rule. Yeah. All. True all. Now, NAGSAG does have it. By the way, I always tend to tack on it. There's another one I'm going to add in a minute. But I'm adding it really for A-level purposes rather than GCSE, but I'm going to add it in a second. The next one is acetates. Is that right? Hang on a sec. Yeah. Acetates. Now, acetates, this is a tricky one. Yeah. Acetates are the salts from vinegar, from acetic acid. Yeah. All acetates are soluble. And I'm going to I will explain that because acetates freaks people out. All acetates are soluble. Are soluble. All acetates are soluble. All. Next one, group 1. Yeah, group 1. All group 1 salts. Group 1 salts are soluble. So, soluble. So when I give the first rule of they're all soluble, it actually fits into these top 3. Yeah, I will explain the acetates. I haven't forgotten. These are the true everything. Yeah, these are soluble. So I'm just going to talk to you about the acetate one. Yeah, so we know that if we take so let's actually do each one of these. Let's do each one of these. Nitrates. Yeah. If I take sodium metal and or in fact, let's go crazy. Let's go for someone unusual. Let's go for iron metal in nitric acid. I am going to form, iron tends to, by the way, I always say to you with you guys, the transition metals are most commonly 2+. Yeah, but iron breaks that rule. Yeah, it's mostly 3+. So I'm going to form iron nitrate. And the question I'm going to ask myself, and hydrogen, metal plus acid goes to salt and hydrogen. We know this, mash. Yeah, we know this, masha. So technically it's 2, it's a mash. Why does the definition say in water when some things are fat soluble? Oh, Libby, great question. Right, so You're right, Libby. There are an awful lot of solvents out there. Well, do you know what? When I say that, there actually isn't as many as you'd think. Yeah, there's kind of not as many solvents as you'd think. There's ethanol, water, and oils. You know, there are all the organic solvents, but we kind of just lump them into the oil ones. And fat is also an oil one. And so when we talk about solubility, it's a bit like, so this is to answer Libby's question. If we have solutes as a family, yeah, if we have solutes as a family and we've got millions of solutes, yeah, if we have solvents as a family, there aren't actually as many as you think. And in fact, pretty much all of the solvents are water. Yeah, water, I should do it in blue, shouldn't I? Yeah. And then you have these extra, most things are dissolved in water. So all of this is water. And then you have a tiny amount of extra solvents. Yeah. And these would be things like ethanol. Yeah. If this is H2O. Yeah. Yeah. This is ethanol. This is oil. Yeah. Other ones include acetone. Yeah. Propanone. Another one, if you like. That's your nail polish remover. But there aren't that many. Like, most things are dissolved in water, Libby. So we just use that as our base definition. I hope that helps. Yeah, there are very, very few solvents in reality. Yeah, if you ever play the game of find the other solvent in the house, you know, everyone goes, orange juice is a solvent. And I'm like, no, it's not. It's stuff dissolved in water. And then they say milk. And I'm like, fat in water. Yeah, most of the stuff is dissolved in water. So we use it as our base definition. Good question, then. So the question I've done, now that I've done the equation here, I need to, of course, balance it. Yeah, I'm going to need 3 of those, going to need 3 of those, going to need 3 of those, I'm going to need 1.5 of those. And now I double it. You get the point. Yeah. So the question is this aqueous? Yeah, question mark. Soluble? Soluble? And the answer is yes, it's going to be aqueous because all nitrates are soluble. So what about the acetates? If we take iron metal and we dissolve it into vinegar, and this is the formula for vinegar. This is ethanoic acid. Ethanoic acid is the proper name, otherwise known as acetic acid. Yeah, and there's the acetate. There's where the salt comes from. Yeah, I'm going to form iron acetate. Yeah, or iron ethanoate is what I'm going to form. Yeah, so iron brackets CH3COO brackets 3 plus hydrogen gas. That there is iron 3 acetate. Yeah, it's the salt from vinegar, and all acetates are soluble. So it's just nice for me to explain that to you. And the word acetate comes from, by the way, that's linking the old name across to it. In reality, I'd never use that. This is dead. Yeah, this is old school. Yeah, old school. Yeah, if you ever go into industry, they hate it if you don't know the old school names, but, well, I mean, whatever. And this is actually iron, if you want to use the proper name, iron 3 ethanoate. Yeah, ethanoate. Gains the 8. Yeah, like nitrate 8. Yeah, telling you it's a salt. Anyway, so all acetates are soluble and all group 1s are soluble. And it truly fits. I'm going to add another one here. Yeah, I'm going to add a nota bene in this bit. The problem is I want to get rid of all my equations now. I shouldn't really do that. I shouldn't really get rid of them. I should move them, really. Because I think equations are always useful. Yeah, let's move him over there. Yeah. So there is one more I want to add. Nota bene. This is more for A level. All fluorides. Yeah, all fluorides are soluble. We don't usually, it's a very rare thing to come across a fluoride. Because if you've got a fluoride, you will have had to use hydrofluoric acid, which is terrifying. It's really, really scary stuff. I've probably talked to you about hydrofluoric acid. Very small, dissolves, passes through your skin, and then eats your bones from the outside. Scary stuff. So you don't really need it at GCSE, but it's a useful rule to have. All nitrates, all fluorides. It's nice. All acetates, all group 1, so NAG. So these fit into the all routine. Now we pick up SAG. Yeah, and this is where our exceptions come in. So we've got sulfates, sulfate salts. We have ammonium salts, and we have group 7. Yeah, group 7 salts. So now here's the clever bit. Yeah, This is where you laugh at me and you go, this is stupid. Yeah. All sulfates are soluble except there is an exception now for the sulfates. Yeah. All soluble except. All soluble except. Now, what this means is, I love rule number 1. I love rule number 1 because what that means is all you actually have to do is learn the exceptions. And I'll teach you the way to learn those too. It makes sense. Yeah. Learn the exceptions. Except. I'm actually going to underline that. Except. Yeah. And I'm going to come back to that one in a minute. I'm going to star that there, saying that there's an exception. The next one are ammonium salts. All soluble. No exceptions. All soluble. Wow. All soluble. No exceptions. So technically, the ammonium salts should actually be up here, but that'd be a nagasug and nagsug. Yeah, I did actually, when I originally started this, I used to teach nagsug. Yeah, this is actually the way I used to teach this. Nagsug, like that. But the problem is no one remembered it. They all got a bit confused because the acetates and the ammoniums came together. Yeah, but you can do that if you prefer. Whichever way you want, do it. You can choose it. I'm just offering you methods. Yeah, but I just like to put nagsag and then the ammoniums can actually go in the top. Yeah. Next, all soluble except. Yeah, so except. And this time I'm going to change my color. Yeah, I'm going to change this from a red to a green just to kind of differentiate between the two. All soluble except. Right. Now, I'm actually going to be tying 2 people to these things. So now you learn the exceptions. And in reality, exceptions. This is actually the bit I need you to walk away with today. I know that nagsag's great, but in reality, it's much more important that you just learn. If you're just going to learn your exceptions, by the way, you can kind of exclude all the rules. You can just kind of go, you know. So there were 2 things that I'm going to teach you. The first one is PMS, exceptions. Okay, first one, exceptions number 1. PMS. I love, by the way, I changed PMS to PMS. It was something else before. I'll show you. It used to be LMS. But I changed it to PMS because I thought it was funnier. So anyway, PMS. And the P stands for plum bum. It's lead. Yeah. Lead. M stands for mercury. Exception, lead, mercury, and silver. If you want to change it, year 10, you can. Some students prefer LMS. I know that some do. If you want to do LMS, you can. I prefer PMS because it's easier to remember. Otherwise, go, oh, what was that letters? But then I go, oh, it's PMS. So you can choose however you want to do it. You can modify my teaching method if you prefer, but this is lead because the symbol for lead is plum bum is PB. Yep. Okay. So let's now color code these. Yeah. Let's color code this. Let's color code PMS in red. Yeah. Let's put a red star on it. What that means is it ties to the sulfate. But here's the other tricky bit. I'm sorry, guys. I'm doing my best I can to. These are the methods that I've been doing for years. And it does work, I promise. Oh, LMS are my initials. No way. There we go. You can everyone go, just remember Laura. I don't know what your middle name is. LMS. Just remember Laura. So, what I'm hoping you guys are going to realize is I have tied, because of these, I have tied them to both the group 7 and the sulfates. What that means is for, PMS reminds me of postmenstrual syndrome. It's not post, it's pre. Lynn's corrected here, that's amazing. Dom, that's why I did it, because I found it entertaining. Yeah, I think it's the same. Premenstrual stress or syndrome. Yeah. Premenstrual syndrome. So What that means is I have tied them across, and now we need to do the examples for this. Yeah? So now we go, hang on a sec. So what does this mean here? This means, so if I go lead sulfate, yeah, lead 2 sulfate, lead's usually 2 plus, you learn it as a plus 2. Yeah, lead sulfate, white solid. There you go. What about, I go mercury chloride, Hg, mercury's a hug, but without you. A hug without you is just toxic. See what I did there? Because mercury is the word hug with. Without the you and mercury, I'm going to stop. So, if we pick anybody, if that hurts.
Amazing. All right, guys.
Sorry, there we go. Oof. So, if I choose any of PMS, yeah, Mr. Duncan, you sound like a player. Yeah. If we pick any of PMS, lead, yeah, mercury, or silver, and I mix them, I join them, I add to them, yeah, let's go, add, yeah. If we add them to, you know, any of group 7s, any sulfate, if I add them to this, 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 except the fluorides. The fluorides overrule that because all fluorides are soluble. It's nice that you say. Clever. These are the group 7s. Yeah, so if I add them to any of these, they're going to be insoluble. Just to tell you there are others as well. Carbonates as well. Yeah, lead carbonate insoluble, mercury carbonate insoluble, silver carbonate insoluble. It actually applies to the carbonates as well, but I haven't put the carbonates and the salts because it just didn't really go into. I learned NAGSCAG. Yeah, I could do NAGSCAG. God, I could totally teach NAGSCAG. You're such a NAGSCAG. God. Such a skag-a-nagger. I'm going to stop. I'm so sorry, folks. Ignore me. I'm sorry. So if I do this table, all of these guys are going to be insoluble. Yeah? So I'm going to have lead sulfate. Solid. It's insoluble. It can't be aqueous. Mercury sulfate. Insoluble. Solid. Silver sulfate. Remember that silver's a +1. Mercury's a 2. Lead's a 2. Yeah? That's a solid. Yeah? Lead chloride. Lead 2 chloride. Solid. Mercury 2 chloride. Solid. Yeah? Silver chloride. Solid. Oh, year 10. Amani, are you still there? Let's see if Amani is here. Amani, what color is silver chloride as a solid? Let's go for the next one. Lead 2 bromide. Solid. Mercury 2 bromide. Can you tell me what color silver chloride is, please, Amani? And then silver bromide. You've got to roll your R's, guys, whenever you do a bromide. Solid. Amani, what color is silver bromide, please? Well done, Amani. Everyone give Amani a round of applause. Well done, Amani. Great job. It is indeed white. Can you now tell me the color of silver bromide, please? Lead iodide is solid. Yeah, mercury iodide. Yeah, it's a solid. Silver iodide. Solid. Yeah. Amani, what's the color of silver iodide, please? I want my 3 colors in a row. Yeah, and then the carbonates as well. Carbonates are also solids. Yeah. So lead carbonate, solid. Lead carbonate. Mercury carbonate, solid. Yeah, all solids. They're all exceptions to rules. Yeah. A light yellow. You're not allowed to call it that, Amani. Try again. It's not yellow. Yeah, this one and this one. Yeah. These are 2 different colors. You've got to know exactly how to phrase it. And iodide is yellow. Yes, it is. Silver iodide is indeed yellow. Well done. That's correct. So white, blank, yellow. Come on, Amani. Come on. Can't say pale yellow, not allowed. It's got another word beginning with C. Come on. Yellow solid. There we go. Silver carbonate. White solid. Yeah, white. I've gone a full hangman on you here, Amani. I've gone full hangman. I don't know. Give me a letter, Amani. Give me a letter. Give me a letter. Give me 3 letters. I'm just thinking because of the delay. We're going to be taking a while to do this. White, something, an O. No O, Amani, I'm afraid. No. No, it's no O. Give me another one. Give me another one. C. The C's are, C though is the creme brulee. Really, A. There you go. Give me another one. Oh, N. N. No N. No N. So you give me an O, you give me an N. A. You already got A. Give me another one. Give me another one. Give me another 3. I'm sneaking into your lesson. Hi, Ananya. Aww. It's lovely to see you. Aww, you're always welcome to come to my lessons, Ananya. Always. Well done. You got the R. Come on, Amani. You can give me the word now. You've got it. Come on. Come on. Hey, Ananya. That's so funny. Crane? What? You? What? How are you doing this, Amani? Look at the letters you... Thank you. Flipping X. You figured it out. It's cream. That's amazing. Did you just do a keyboard slam? That's amazing. I love it. White, cream, yellow. Well done. Okay. So we've covered PMS. Second rule. Yeah, second one. Rule number 2 for the exceptions is Castrobad. Castrobad. Yeah. Oh, look at... Oh, Ananya, you are loved. Aren't you in this class? Sophia's probably confused. No, she left. Castrobad. Castrobad. I just like to teach Castrobad. It's cool. Yeah, Castrobad. And what it is calcium. Calcium, strontium, barium. And the great thing is, technically, I used to teach this differently because these are all part of group 2. I used to just teach the bottom of group 2. Yeah, I'd be like, remember PMS and group 2. Yeah, there you go. The bottom of group 2. There we go. Remember, we don't talk about the radioactives. We don't talk about those. So it's just the bottom of group 2, bottom 3 in group 2. Castrobad. So now Castrobad, we realize that PMS applies to both. Yeah, PMS, there we go. PMS applies to both exception rules. Yeah, but Castrobad doesn't. Castrobad only links to the sulfates. Yeah, exception, sulfates. Yeah, you can. I hope you understand my little tagging them with the little stars. Yeah. So if these are just calcium chloride soluble, calcium bromide soluble, strontium chloride soluble, all the Castrobad only applies to the sulfates. So let's look at what this looks like. If we take calcium, strontium, and barium, and we mix them with the sulfate ion, yeah, then we're going to form insoluble salts. Calcium sulfate, solid. Strontium sulfate, solid. Yeah. Barium sulfate, solid, insoluble. Yeah. And that's it, guys. PMS and Castrobad. Otherwise, everything's soluble. Isn't that awesome? Do love it. Just link it to SAG as well. Sulfates in group 7s. And that's it. I like the game. I didn't even get to hang Ananya. No. Amani. Ananya, I'm trying to hang you already, and you've only just turned up back in the class. It's amazing. Sorry. Didn't mean to say that. Yeah, so really handy. Castrobad and PMS. That is it. That's it. That's all you need. And all fluorides are soluble. I love throwing that one in there. So let's now put this into action. Okay. So we can now go practice. Have I just missed a C out? Practice equations. We need to understand what this looks like from a reaction perspective. Practice equations, brackets, reactions. Okay, so let's take lead nitrate. Lead nitrate. On the chat, please. Aqueous or solid? Which one? What is the state symbol here, please? I'm going to add that to potassium iodide. Aqueous or solid, please? And now, guys, can you now give me my products? Yeah, on the chat, I want two state symbols. Amani, thank you so much. Amani is now on it. Lara, Haoping, well done. First one is absolutely correct. It is an aqueous. Why is it aqueous, please, Sophia? Why? How do you know it's aqueous? What's the rule? Good job, Lynn. What about the Ki? Yeah, what about Ki? Is that solid or aqueous? Caitlin, well done. So, guys, you've given me the answer to this one. Can you now give me Ki? Give me the symbols before it so I know which one you're tagging. Yeah, potassium iodide. What's it going to be? I have to just assume the gap, you see. That's the problem. Yeah. On the chat, please, can you now give me the full equation, please? This is where you're just applying your rules that we've picked up. So we realize that this one's soluble. How did you know? Yeah, all nitrates are soluble. Always a great rule. How did you know that this one's aqueous? Potassium iodide, aqueous. How did we know? All group 1s are soluble. They dominate. Most things are soluble. The question is, what am I going to make? What are my products? Give me my products, please, and their state symbols. Please, please, please. Please, please, please. Come on, guys. Come on. Come on. Come on. Come on. Dragging you over the line. Aqueous, aqueous, lead nitrate, potassium. Okay, right, cool. So, Haoping's giving me the right things. Remember, if you're not sure, swap. If you're not sure, swap the metals. Yeah? Find the metals, switcheroo. Yeah, we know this. So I'm going to form lead 2 iodide. Yeah? And potassium nitrate. Right, balance the equation. 1 lead, 1 lead, 2 nitrates, 2 nitrates, 2 potassiums, 2 iodines. There you go. All adds up now. Yeah? Now the question is, what are the state symbols going to be? Yeah? What are the state symbols going to be, folks? Put them in order. Yeah? On the chat, I want this one to be the first. Yeah, and this one to be the second. Just trying to read, I'm showing you how it ties to the equations. I'm then going to show you what it looks like. Haoping, well done. Good job, Haoping's on it. Lead iodide is now as all nitrates are soluble. Well done, Tiff. Well done, Imani. You're starting to understand what I'm doing. Well done, Caitlin. Wait, why is there a 2 in front of lead nitrate? Sorry. Thanks, Lara. Oops. Made a mistake balancing my equation. I went too quick. My bad. So we see an exception to the rule. We see PMS appear. Yeah, there's PMS appearing. Yeah, we realize that PMS, lead, mercury, silver, if you have group 7, yeah, group 7 or a sulfate, or a carbonate. What am I doing? Sulfate or a carbonate, you're going to be insoluble. Do you want to see what this now looks like? This is a great reaction, this one. So this is where I need to tell you to go to a YouTube video. We're watching a YouTube lesson with a YouTube video within a YouTube video. That's weird, isn't it? It's weird. It's very weird. Do you want to see what this looks like? So guys, yeah, lead, nitrate, and Ki. Let's just see a little look. There we go. So what would it look like if you have, remember, aqueous means, just going to get rid of the sound. So he's adding them to water. Guys, you should definitely watch some of these. Yeah, they're really good. They're cool reactions. I'm bored of this already. So I'm already bored. Go away. I'm going to get rid of it. So what would this look like in a picture? This reaction would look like this. Just going to get rid of those rules. Yeah. So what would this look like? If I had this in a beaker, if I had lead nitrate, yeah, in a beaker of water, it would be a colorless solution. Colorless solution. If I had potassium iodide in a beaker in water, it would be a colorless solution. Yeah. If I now mix them together in a big beaker, what would I now see happen? It turns bright yellow and it goes completely opaque. Yeah. Opaque. Can't spell opaque. Opaque yellow. The reason why is because lead iodide is a yellow solid. That there is a yellow solid, which is going to form a cloudy mixture. It's an amazing, it's actually like yellowy gold. It's really a beautiful reaction, actually. A reaction video. Okay, let's try another, let's try another equation. Let's do barium metal plus sulfuric acid. What's the state symbol for all acids? State symbol. Can everyone now complete that equation for me? What am I going to make and balance? Go, go, go. Pause the video and have a go. You have homework after this as well, guys. Aqueous, well done. All acids are aqueous. Great rule. All acids are in water. Are aqueous. Are AQ. Are dissolved in water. If an acid isn't in water, it ain't an acid. Why? Because this is what we've also talked about. Why is that? Because when it goes into water, when we add an acid to water, it splits. We know this. Yeah? When you add, and that is what makes an acid. The hydrogen ion is what makes an acid an acid. pH. Yeah? The H stands for hydrogen. It's quite nice to remind ourselves of the acid-base theory. Isn't it cool how everything ties together? It's really cool, that, isn't it? So we've got barium and sulfuric acid. What am I going to form, folks? Come on. No one's put on the chat yet. Come on. Come on. Thank you, Laura. I'm going to form barium sulfate and hydrogen. Amani's on it. Look at that. And barium sulfate. Castrobad. Castrobad. It's a sulfate. Yeah, this one is going to be a white solid. Well done, Hao Ping. He's all over it. Look at that. Isn't that an amazing equation? We have nearly every, the only state symbol we're missing is water. Amazing. That's liquid. Yeah, it's amazing. I love it. We've got solid, we've got aqueous, we've got gas. It's amazing. It's boss. Loving it. I'm loving it. And that's a white solid because there's Castrobad. Yeah. We see Castrobad. We go, oh, the reason being is because Castrobad. Yeah, Castrobad tells me that it's insoluble in a sulfate. Yeah, SO42 minus, they're insoluble. Winner. Next. Let's go for another one. Let's go for another one. Yeah, let's go for another one. I don't know. I'm trying to think of the ones you might see. Silver nitrate. No bracket needed. It's 1 plus. Come on. Silver nitrate plus sodium carbonate. Ooh. Right, guys, off you go. Yeah, give me state symbols. See if you can figure this one out. Go. Remember, if you're ever not sure, swap the metals. You know this rule. We're getting good at this rule. What am I going to get there? Ananya, I'm back. Hi, Libby. Oh, man, Ananya's back. So, give me my equation, guys. Remember, switcheroony. Swap your metals if you're not sure. Yeah, just switch your metals. Switchy. I've lost my mind. I'm so sorry. Oh, no, I've gone Yorkshire. I've gone a little bit crazy. Not very good at the Welsh accent. Need to work on it. State symbols. Too slow. Ag2CO3. Wonder who's going to give me that formula that's going to be correct. Plus sodium nitrate. Right. Balance. 2 silvers. 2 nitrates. 2 sodiums. It all adds up now. Done. Right. State symbols. State symbol for silver nitrate is aqueous because all nitrates are soluble. Sodium carbonate, state symbol, aqueous because all group 1s are soluble. Silver carbonate, PMS. It's a solid, a white solid. Yeah, and sodium nitrate, all nitrates are soluble, aqueous. Yeah, it's a fun game. This is a fun game. So we're getting good at our equations now, guys. It's all about practicing these equations. That brings me to the end of my lesson. Just going to check my learning objectives. Let's have a look. Solubility rules, definitely done that. How solubility affects reaction. Well, we've seen that. We're seeing precipitates forming, done that. Write equations with state symbols, done. Yeah, amazing. So, I haven't really done number 2. Affects reactions. It actually stops some. I'm tempted to talk you through that. Anyway, to bring us to the end of the lesson. Right, guys, I'm done. Solubility rules. Lockdown has broken me. Anyway, guys, I'll put your homework on the classroom. Thank you for being here. It's great to see you, as always. Ananya, it's so good to see you. I hope you're well. It rules. Thanks, Zach. Thanks, guys. I'll put your homework. It shouldn't take you very long. It's only 1 sheet, I think. Shouldn't take you very long. Wait, what happened to the goatee? You've just noticed. The lockdown goatee has gone. I had to get rid of it. It was driving me crazy. It's growing back though already. Mr. Duncan rules. Thanks, Dom. High five, Dom. Boom. Virtual high five. Right. Guys, I will post your work on the classroom. I'll see you tomorrow. Make sure you get your homework done. I'll post that immediately. See you later, guys. Have a great rest of your day. You can do it now. You've got 5 more minutes of the lesson. See you soon. Bye.